This is First Coast Math Clinic with Lesson 8, Probability, from Unit 5, Percents. So the goal in this video is to find the probability of an event occurring. So let's talk about probability first. So probability is the likelihood of an event occurring, and probability is always written as a ratio. So probability, our notation is going to be kind of this function notation. So we've got P for probability, and then whatever event we're looking for in parentheses equals, and then our ratio, our fraction, our favorable outcome, so what we're looking for in our numerator, over all possible outcomes, so everything that can occur in our denominator. So our numerator is what we're looking for, our event in our numerator. Our denominator is all possible outcomes, so everything that could happen in our denominator. So let's look at our example. If a die is rolled, what is the probability of the die landing on an odd number? So we want the probability of an odd number. So our event is going to be an odd number. So let's think of what our favorable outcome is and what all possible outcomes are. So our favorable outcomes, if we think about a die has numbers 1, 2, 3, 4, 5, and 6. So our favorable outcomes are going to be our odd numbers, right? That's what we want. So that's going to be in our numerator. So odd numbers are going to be in our numerator. Our denominator is going to be all possible numbers, or all possible outcomes. So the odd numbers in our die, 1, 3, and 5. So we've got 1, 3, and 5, right? So we've got 3 values that are odd. Write that a little neater. And all possible outcomes, well, we've got 1, 2, 3, 4, 5, and 6. So we've got 6 possible values in our denominator, 6 possible outcomes for our denominator. So we've got 3 over 6. 3 over 6 reduces to 1 over 2. So our probability of an odd number is 1 over 2. So for every 2 rolls of the die, we should have an odd number 1 time. All right, let's get into some examples of probability. So a common example of finding probability is rolling dice. And in this example, we've got a table for rolling 2 dice. So this is going to be die 1, and this is going to be die 2. So die 1, values 1 through 6, and die 2, values 1 through 6. So we're arranging this in kind of an ordered pair, so we can roll a 1 and 1, a 2 and a 1, or 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, and then a 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, and so on. So our question is, if 2 die are rolled, what is the probability of the sum of the die of the 7 die greater than or equal to 9? So we want probability of a sum greater than or equal to 9. So that's what we're looking for. So when we set this up, our favorable events are going to be our sums greater than or equal to 9. Our denominator is going to be all of our total outcomes. Well, how many total outcomes do we have? Let's figure that out first, right? So our total outcomes, we have 6 possible outcomes for die 1, 6 possible outcomes for die 2. So 6 by 6 gives us 36 possible outcomes. We could just count up the squares here to figure out how many total possible outcomes we have. So we've got 36 total possible outcomes. Of those 36, right, so that 36 is going to be our denominator. Of those 36, how many have a sum greater than or equal to 9? So let's look at our possible outcomes, right? So the way we're going to do that is basically just add up the two values in each square. So here I've got 2 and 6, so I'm going to get an 8 here, and we kind of notice a pattern, right? So 2 and 6 gives me 8, 3 and 5 give me 8, 4 plus 4 gives me 8, 5 plus 3 gives me 8, and 6 plus 2 gives me 8. So this line all give me 8, and everything to the left here are going to give me values 8 or lower. So I want values that are basically to the left, to this side, okay? So let me highlight those in yellow, it's a little easier to see. So if we look at right here, right, we've got 3 and 6, we know that sum is going to be 9. 4 and 5, that sum is going to be 9. 5 and 4, that sum is going to be 9. And 3 and 6, or 6 and 3, that sum is going to be 9, because we want a sum greater than or equal to 9. And if we move to the right, we've got 6 and 4, so our sum is 10. 6 and 5, so our sum is 11. 5 and 5, sum is 10. 4 and 6, sum is 10. 5 and 6, sum is 11, and 6 and 6, sum is 12, right? So these values here that I've highlighted all have a sum greater than or equal to 9. So these are the values that we're going to be referring to as our favorable outcomes, are sum greater than or equal to 9. So how many values do we have? How many possible outcomes do we have that are greater than, have a sum greater than or equal to 9? Well, let's count them up, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible outcomes out of 36 have a sum greater than or equal to 9. Well, we got 10 over 36. We could reduce this a little bit, so we could break this up. 2 times 5, 2 times 18, 2 and 2, divide and divide into 1 and 1, and we're left with 5 over 18. So our probability is going to be 5 over 18. So for 18 rolls of 2 die, 5 times we're going to get sums greater than or equal to 9. All right, let's look at another example that have 2 dice rolled. So here, for this example again, so we've got the same setup. So we've got die 1, die 2. We're looking for probability, but we want to find the probability that the sum is a prime number. So let's just review prime. We know prime numbers are numbers that are divisible by 1 and itself. So if we think of just some basic prime numbers, right, our largest sum here is going to be 12. So we don't have to get too large. We can go 2, 3, 5, 7, 11, 13, 17, okay? So we can stop there. So those are our basic prime numbers that we're going to work with. And we want to figure out, well, from these combinations, which combinations of outcomes from die 1 and die 2 are going to give us a sum of either 2, 3, 5, 7, 11, 13, or 17. So let's set up, we want the probability of a prime sum. So our favorable outcome will be the number of prime sums Our denominator is going to be the number of total outcomes. Well, we know from the previous problem those total outcomes are going to be 36. Well, how many prime sums do we have? So let's go through and just figure out which combinations, what combinations are going to add up to 2, 3, 5, 7, 11, 13, or 17. So let's start 1 and 1. Let's start with 2 first. So 1 and 1, we know that's going to give us 2. So nothing else is going to give us 2. Let's try 3. So we could do 1 and 2, and 2 and 1. So nothing else is going to add up to 3. Let's do 5. So we could do 1 and 4, 2 and 3, 3 and 2, and 4 and 1. So we kind of notice maybe like a little pattern here, right? Let's try 7. So 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 1 and 6. 11, we're going to have 5 and 6, and 6 and 5. And then the largest sum is 12 from 6 and 6, so we won't be able to get 13. So let's count up how many possible combinations we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 possible combinations that have prime sums out of 36. So let's factor this out. We could do 3 times 5, and then 3 times 12. The 3 and the 3 divide out, and we get 5 over 12 as our probability. So if we roll 2 dice 12 times, 5 of those 12 times, we're going to get a sum that is a prime number. All right, so a common application of probability is involving decks of cards. So if you're dealt 1 card from a deck of cards, what is the probability of the card would be an ace, a heart, or a 5, or a queen? So let's just go through some information about a deck of cards. So we know that our total from a deck of cards, any deck of cards has 52 cards, 4 suits, 13 cards per suit. So our suits are going to be our hearts, spades, clubs, diamonds, okay? So let's start with number 3. We want to figure out what's the probability of an ace. So probability of an ace. So we've got 52 total cards. Well, how many aces do we have? We only have 4 aces in the deck, so 4 out of 52. And we can simplify this to maybe 4 times 1 and 4 times 13. 4 and the 4 divide out, so we'll get 1 out of 13 as our probability. So if we pull 13 cards, every 1 card out of 13 should be an ace. Now a heart, so we want the probability of a heart. Now a heart is a suit. All right, so we've got 52 total cards. And how many cards per suit? So we've got 13 cards per suit, so there are 13 hearts in the deck. So we can factor this out, 13 out of 52. So we can break this up maybe to 1 times 13. And 4 times 13. So the 13 and the 13 divide out, and we're left with 1 over 4. So the probability of pulling a heart out of a deck is 1 out of 4. So you've got a better probability of pulling a heart out of a deck than you do an ace, because there are more hearts in a deck than there are aces. So every 4 times you remove a card from a deck, you should get a heart. Now number 5, we want the probability of a 5 or a queen. So again, we've got 52 cards. Well, how many 5s are there? There are 4 5s. How many queens are there? There are 4 queens, so this is 8 out of 52. We can factor this a little bit, so 8 is 4 times 2. 52 is 4 times 13. 4 and 4 divide out, we get 1 and 1. We're left with 2 out of 13. So our probability is going to be 2 over 13. So every 13 cards that we pull from the deck, we should get a 5 or a queen 2 times. Okay. All right, so this video has been Unit 5, Lesson 8, Introduction to Probability. If you like this video, leave a like, comment, and subscribe. I hope these videos are helping you guys out. Again, if you like this video, leave a like, comment, and subscribe. If you want to see any additional videos made, just leave the topic in the comments. First Coast Math Clinic.